Okay, I'm going to solve all the problems from the whiteboard review to prep you for the Unit 2 syllab. All the learning targets that are on this page are part of the Day 1 or the Part 1 celebration. And then the ones that are on this slide would be Day 2. Alright, so let's start solving some of these guys. So first one, sketching the graph. So we just have a little rough graph, and then the vertex, of course, would be -2, 5. So we plot that, and then the zeros are -3 and -1. So those would be where it crosses the x-axis. So this would be -1, that would be -3, and then the parabola just opens downward. This next one, the vertex is 4, 0. So 1, 2, 3, 4, 0. It says that there's only one 0, that x equals 4. So this one could be a parabola that opens upward, or it could be a parabola that just opens downward at that same spot. So it could be like this, hits. But the point is it just has one x-intercept, 1, 0 there right at 4. And just make sure you also know how to do the ones that have, no real zeros. And if it's no real zeros, then it could either be a graph that would go up like that, or it could even be a graph that goes like that. And then you just, of course, plot whatever vertex you're given. Okay, next one, the vertex. So we can tell the vertex here is right there, so that's 0, 2. The axis of symmetry, remember, is always a vertical line. So that's the line that cuts the parabola in half, and that is x equals wherever that vertex is. So the x coordinate of the vertex. So that's going to be x equals 0. And then the zeros, again, are wherever it crosses the x-axis, so we have to put x equals, and that's -2 and 2. The end behavior says what's happening to the graph as x approaches infinity. What's happening is the graph is going down, so it's getting more negative. So y is approaching -infinity. As x approaches -infinity, the y value is also getting bigger negatively, let's say. So -infinity. And then the increasing interval, that's always from the left to the right. So the graph is going up, it's increasing this whole time. So we would give the interval in terms of x's. So this is -infinity all the way to 0, right at that halfway point where the vertex is. And then it's decreasing this whole time. And so that's going to be right at 0, it starts. And then it's decreasing this whole time all the way to positive infinity. Okay, we want to be able to give the transformations. So remember that whenever there's anything going on inside the parentheses here, that's always dealing with the x's. And so this, x plus 4, means that it's actually shifted 4 to the left. So shifted 4 units to the left. Whenever it's outside of the parentheses, it's the y values. So this, -11, means that it is shifted down. So this is down 11 units. And then when there's a number that's in front, like right here, that means that it's either going to be vertically stretched or it's going to be vertically compressed. This number is less than 1, and so it's going to be vertically compressed. So vertically compressed. It's vertically compressed by a factor of 0.25 because you're actually multiplying it by 0.25, but we'll be okay with vertically compressed. And if you happen to have a negative sign in front of this, then that's where you would say reflected, over the x-axis or something like that. But this one's not reflected, so it's still just opening upward. Okay, solving by taking the square root. Eventually you're taking the square root, not necessarily right away. So we just go about our business. We're solving this, so we're going to try to isolate the x. So that means you're just adding 24 to both sides. So we add the 24 over, and then we divide by 2, and so we get x squared equals 12. And then you want to take the square root, and when you take the square root, you always have to remember that you have plus and minus. And it's square root of 12, but we can actually break it down a little bit. So 12, think of the perfect squares that are factors of 12. So like square root of 4 times the square root of 3. And you can take the square root of 4, so that's why this simplifies, because the square root of 4 is 2, so that's 2 square root of 3. So our best answer would be to say plus and minus 2 square root of 3. Okay, next one. This actually with the calculator, so I won't be able to show this one as well because my calculator doesn't work from home. But so what you do is you replace the 0 with a y, and you just graph this. And then when you graph it, you're looking for the real zeros. You're looking for where it crosses the x-axis. These are your x-intercepts. And so you do second calculate, and you move it to the left of the 0, and you press enter, and then you move your blinking dot to the right of the 0, and you press enter, and then it says guess, you press enter again. That'll give you where it crosses. This particular one crosses at 2 spots, so at -2 and at 0.5. But the one on the celebration will require you to round it to the nearest hundredth. So it'll be, not so much like rational numbers here. All right, solve by factoring. So this is I call this the harder type of factoring. So it's when you have a number in front of the x squared term like that. So we're gonna have to multiply the 3 times the 14 first. So that gives us 42. And we have to look for 2 numbers that multiply to be 42, and they add up to be -23. Okay? So that takes a little bit of thinking, but eventually you'll come up with the numbers, -21 and -2. What we do with those numbers is we rewrite the middle term using those 2 numbers. So -21, and we put a little x on them as well. So -2x, and then plus 14. Notice we just rewrote the trinomial as 4 terms instead of 3 terms. So now we're going to factor by grouping. So the first 2 terms, we pull out what they have in common. So they have a 3 in common as well as an x. And that leaves us with x minus 7. And then the last 2 terms, we look to see what they have in common. So they have a -2 in common, and that leaves us with x minus 7 equals 0. Then we're happy because we see that they both have an x minus 7 that's in the parentheses. So that's one of the factors, x minus 7. And then when you pull that out, what's left is 3x minus 2. So that's our other factor. And we set that equal to 0. So we take each of these little factors and we set them equal to 0 to get our answers. So each of these separately. So this one turns out to be 7. And then this one is a 2-step. So add the 2 over, then divide by 3. Just make sure you take the time to do that. So you get 2/3 instead of 3/2. So it's supposed to be 2/3. All right, 2 good answers. Okay, this one's factoring. So you have to notice that this is a difference of 2 perfect squares. That's a perfect square, that's a perfect square, and it's a difference. So this is a pattern that you recognize. So square root of those, this is 4x and 4x in the first spot. and then the square root of 1 is 1, so that goes in that spot, and it's always alternating signs. So then after we factor it correctly, then we just take our little factors and we set them equal to 0 and solve for x. So we get x equals positive 1/4, and then we get x equals negative 1/4, so 2 good answers. Okay, quadratic formula. So definitely memorize the quadratic formula, but here it is. So it's going to be x equals negative b plus and minus big old square root b squared minus 4ac, all of that over 2a. Notice the discriminant is in there, that b squared minus 4ac part of the quadratic formula. So let's first identify our a, b, and our c. So a is whatever's in front of this, it's the coefficient in front of the squared term. So b is this number, so that's a 1. And then c is the constant, so c is 3. So then we start plugging it in. So we're going to do x equals the opposite of b, so whatever b is, we do the opposite of that. So negative 1 in this case, plus and minus b squared, so that's 1 squared minus 4ac, and then all that over 2 times a. X equals negative 1 plus and minus big old square root 1 minus 12 over 2. X equals negative 1 plus and minus. So it looks like we're going to get a negative 11 under the radical. So we can't really take the square root of 11 anyways, but we can deal with the negative under the radical. So we just use our imaginary unit. So we say negative 1 plus and minus I square root of 11 divided by 2. That's our best answer. Those are 2 good solutions. They're imaginary solutions, but they're 2 good solutions. Okay, this is the one that's sort of partially done. So remember something, when you're solving for x, you're trying to get the x by itself. So sometimes I see people multiplying this thing out. That doesn't help us get the x by itself. We need to get rid of things. We need to isolate the x. So that's what solving for x means. It means getting the x by itself. So if this says squared, then we want to do the opposite of squaring something, which is taking the square root. So we take the square root, that will get rid of the squared, so this will be x plus 1 equals. We can take the square root of 100, so that's 10, but it has this little negative under the radical as well, so we have to use our imaginary unit. So we're going to say plus and minus 10i. Then we're going to continue solving for x, so we're going to move this plus 1 over. So to do that, we have to subtract it over, so we subtract it on both sides of the equation. When we put a little minus 1 there, the minus 1 I like to put in front, so minus 1 plus and minus, and then 10i. So that's our best answer. That's how we can write it. You can't combine those because you have a real part and you have an imaginary part. Completing the square. So when you're solving by completing the square, what you want to do first is you want to move that constant over to the right and leave yourself a nice little blank. So we're going to go x squared plus 12x plus, we're going to leave ourselves a little blank, and we're moving that 3 over to the right. So that's a negative 3 plus a blank. Now this is where we add that magic number. So we look at the number 12, and we take half of that and we square it. So half of 12 squared is 6 squared, so that's 36. So 36 is the magic number that we want to add to both sides. So a little bit of work off to the side. That's 12 divided by 2. That's how you find half of something. And then you square it. So half of it and squared. So that's 6 squared, which is 36. Okay? Now, after you add that magic number, what that does is that creates what's called a perfect square. On the left-hand side, it's a perfect square trinomial, and it always factors as x plus or x minus. If you see a plus sign right here, then you know this is plus. If there's a minus sign here, then there's a minus sign there. So x plus, and then whatever the square root of this number is, goes here. So that's x plus 6 quantity squared. Now again, the reason why this works is because x plus 6 times x plus 6 multiplies together, gives you this x squared plus 12x plus 36. Okay, on the right hand side, this is 33. So kind of like the last problem, we're at the spot here where we want to try to get the x by itself. So we need to get rid of the squared, so we're doing the opposite of squaring it. We're square rooting. Square root both sides. That gets rid of this, because they're inverse operations, and that gives us x plus 6 equals, remember that plus and minus, square root of 33. We continue solving for x. We need to get rid of this plus 6, and that's by subtracting on each side. So we have to put a little minus 6 there, a little minus 6 there. So your final answer would be negative 6 plus and minus square root of 33. Not really anything we can do with the square root of 33. It doesn't have any factors, perfect factors, that are, or perfect squares that are factors. Okay. All right, another completing the square. This time the number here isn't a 1, so we need to get rid of the 2 in front first. So we're going to divide by 2 on both sides. So that's going to give us x squared plus 10x minus 8 equals 0. Now we're back to where we were on that first problem, so we're going to move the constant over to the right. The constant is the number that doesn't have any variables. So we're going to say x squared plus 10x plus, leave ourselves a nice little blank, move this little 8 over, plus a blank. Let's add the magic number. So the magic number is half of 10, which is 5. 5 squared, 25. So 25 will work great. On the left-hand side, that creates this perfect square trinomial. So this factors really well. It's x plus, and then the square root of 25 is 5. So x plus 5 squared equals, and then on the right, it's 33. Okay, now we're going to go ahead and take the square root of both sides. So we take a big old square root, and on the left it's going to be x plus 5 equals, and then plus and minus the square root of 33. And then we're going to finish it out, x equals, we're going to have to subtract 5 from both sides, so a little minus 5 there in front. So it'd be negative 5 plus and minus square root of 33. So again, nothing we can really do with the square root of 33, so we'll just leave it alone. Okay, this one has 4 plus 6i and it's squared. So we want to remember that we have to write this out side by side. This definitely is not equal to 4 squared plus 6i squared. That would not get us the right solution. So what we have to do is we have to write this out side by side. So 4 plus 6i times 4 plus 6i, and then we're going to FOIL this. So we're going to go first times first. So 4 times 4, so 16. Then we're going to do the outside, so we're going to do 4 times 6i, so that would be 24i. Then we're going to do the inside, and that would be also 24i. And then we're going to do the last times the last, so that would be 36i squared. So then we just keep simplifying a little bit. We combine some like terms. So we're going to have 16. We're going to combine these two like terms. So that makes 48i. And then we're also going to deal with this. You have to remember that I squared is equal to negative 1. So that means this right here is the equivalent of negative 36, because it's 36 times negative 1. So change the sign. So now we're going to be able to combine the numbers. So 16 minus 36 is negative 20, and then plus the 48i, and that's the best we can do. It's written in a plus bi form, which is the proper form. Okay, next one is actually easier. So when you have a minus sign in front, you just have to make sure to distribute that minus sign. So this is negative 3 minus 6, so that makes negative 9. And then we have 2i minus 1i, so that just makes plus I. Just make sure you don't multiply those because it's just subtraction. Okay, find the value of the discriminant. This is kind of a part of the quadratic formula. So the discriminant is b squared minus 4ac, and it tells kind of like what kind of solutions you're going to have, how many solutions you're going to have. So we do it the same as we do with the quadratic formula. We should really identify the a, b, and c. So a is 2, b is negative 5, and c is positive 7. So b squared minus 4ac, so that means it's going to be negative 5 squared minus 4 times the a, which is 2, and then times the c, which is 7. And we just multiply that out. So 25 minus 50, what's that? 8 times 7, so 56. So 25 minus 56 is negative something. So negative, what, 56 minus 25, 31. So this would be minus 31 as the discriminant. So in other problems, it has us, figure out what kind of solutions. This one would be 2 real solutions, but that isn't part of this question. I'm sorry, 2 imaginary solutions. Okay, so this question is more telling what kind of solutions you're going to have based upon the discriminant. So if you have a negative discriminant, that automatically means that you're going to have 2 imaginary solutions. And if you have a discriminant that's 0, that means you're going to have 1 real solution. If you have a discriminant that's 100, then that means you're going to have 2 real solutions. All right, and again, the reason for that is because it's part of the quadratic formula. So this really determines, what kind of solutions you're going to have. So I did show my class that, but I'm going to hold off on that right now, I think. All right, this is where we want to try to come up with the equation. So we're going to start off with the form of the equation, the vertex form. So y equals a parentheses x minus h quantity squared plus k. So what we're going to do is we're going to plug in the points, and we're going to solve for a, and then we're going to go back and rewrite it with the a in there and the h and the k. So let's label what we have. Every time we have a vertex, we should label it hk. And every time they give us a point, we should just label it x comma y, some random point that actually is part of the parabola. So we start plugging in the numbers. So the y, it looks like it's 3. The a, we really don't know what that is yet. The x is negative 6, and then it's always minus. And then the h is negative 5, so you got to be careful with your negative signs. And then squared. And the k says that it's negative 1, so we put a minus 1 there. And then we just start showing our work. So 3 equals a. And then in the parentheses, it looks like I have negative 6 actually plus 5, which would be negative 1. I'll show a lot of steps here. So this would be negative 1 squared minus 1. And negative 1 squared is 1. So this is 1. So this is a minus 1 equals 3, and then you would add the 1 over. So then A equals, we add 1, so that would be 4. Now if A is 4, that means what we want to do when we write this is we want to put the A in there, and then the H, and then the K, and that's it. We don't want to plug the X and the Y back in. So our final answer, as nice as can be, would be Y equals 4X. Now it's normally X minus whatever the H is, but because of the two negatives, we would make it plus. So 4 times X plus 5 squared, and then the K is a minus 1, so then we just put minus 1. That's the best form. That's vertex form. Okay, so this application problem, what we do is we just graph this on the calculator, y equals that, and then we just calculate the maximum, second calculate, and whatever the maximum is, we look at the x coordinate, and that will tell us, the time that it takes to reach the maximum point, and then whatever the actual maximum y value is, that's how high it reaches. And then however many seconds it takes for the ball to hit the ground, that's going to be calculating the 0. Where does it hit the x-axis? So I did this one on the calculator, and I found a good window. It's not the only window that would work. It's just a particular window that works. So try that on your calculator. And I got the maximum right here to be at a time of 0.62 seconds. It's rounded to the hundredth. And then I found that the y-coordinate was 56.25, so that means that it reaches, the maximum height of 56.25 feet at a time of 0.62 seconds, and then it hits the ground right here, and that's calculating the 0. So second calculate, you have a blinking dot, you move the blinking dot so that it touches, so that it's to the left of the 0. And then you move it so that it's to the right of the 0, and you press enter to make it guess, and it guesses, bam, right there. That's 2.5 seconds. Okay, similarly with the calculator, you graph two different functions. So you graph this one, y1 equals that, and then this one, y2 equals that. And you're just going to graph them, and of course find a good window first. And then once you find a good window that shows both the graphs, then you just want to calculate the intersection, or intersections if it has more than one. So this one I graphed and found a good window. And then, whoops, didn't mean to do that. So then I calculated the intersection. So second, calculate. It'll be on one of the graphs, and you press enter and it pops to the other graph, and then you press enter again and it guesses the point of intersection. This one intersected at 1.25 as the x-coordinate, and the y-coordinate was 5. So we know that it takes 1.25 seconds for the gull to catch the crab, and he caught the crab at a height of 5 feet. All right. So see me if you're having any troubles with the calculator stuff, but good luck. That should do it.